Hi all, welcome back to another lecture of DBMS series. In this lecture, we will be learning about sharding. In last lecture, while learning about the horizontal partitioning, we have seen that it is also called or it is also known as sharding. What exactly sharding means? And we will be learning about the difference between partitioning and sharding in this lecture, which we were talking about in last lecture, which is one of the most frequently asked questions from the interview. So stay tuned and let's begin with this lecture. In this lecture, we will be learning about sharding, difference between sharding and partitioning. Then we will learn about what exactly a shard key means, management, rebalancing of sharding, and what is the meaning of replication in sharding. So let's begin. First, what is sharding means? So it is also the process of dividing a large database table into smaller, more manageable pieces, which are called shards. So whatever in partitioning we were calling it a partitions, right? A part of database. Here also we will call a part of database that is called shards. And each shard contains a portion of data. So every partition, like how every partition we're holding some data, right? So here also each shard will hold the data and the system routes queries to the appropriate shard based on predefined shard key. So we will have some shards, okay, shard 1, shard 2 and shard 3. And from the database, we will have multiple datas. So on the basis of shard key, okay, it will select on which shard it should route, shard 1, shard 2 or shard 3. So that is what it's saying. Every database will have a shard key, and on the basis of shard key is nothing but the unique value, right? So it can be the collection of unique columns, which actually decides the, to which shard the data value should fall. So sharding typically refers to horizontal partitioning only, where rows of a table are distributed across different shards. So how we have now A, B, C, 101, train IDs, 103, and we have some, let's suppose the dates, right? 10, 2, 5, 15, 3 and 14, 4. This is how we were having the dates, right? So if we are keeping it first row and second row in one partition, any rows in one partition, another rows in other partitions. So if we are dividing the database on the basis of rows, it is also called horizontal partitioning, and hence it is also called sharding. Each shard contains a subset of rows. So hence if you have taken the first two rows for shard 1 and another row for shard 2, so hence each shard contains a subset of rows, yes, but all shards share the same schema. Hence again it is a type of, or it is also called a horizontal partitioning, and wherever you are dividing the table on the basis of rows, hence you are keeping the columns as it is, hence you are maintaining the schema here. So it is here in this case, in the case of sharding also, we are maintaining the schema. For a system like IRCTC, sharding could be implemented by dividing user data or booking data based on geographical regions or train type. So hence on the basis of train type or on the basis of geographical regions, you can divide the data into different shards. Means if you have bookings from Delhi location or Mumbai location or Kolkata location, and if you are saving all those data on in the same location in the same server, it will be overloaded. That is why you have decided to divide the data on the different servers, right? So if you are, let's suppose in the Kolkata server, you are keeping the data or bookings which has been done for Delhi. So it will be, means you have routed it to the wrong place. So if you are searching for some booking which is not even on Delhi server, which should be on Delhi server, but if it is not there, what it could return? That you don't have any bookings, and that will be a false response, right? Or even you have done the booking for Delhi. Now you have to search for Kolkata or Mumbai location, which is not a good option, because if you are doing so, then why you have divided into different shards, right? So you have decided to divide in different shards based on the location. Means if you want to search for any booking which has been done for Delhi or Kolkata, so you will search on Delhi only or Kolkata only, right? So hence we actually keeps a shard key. Shard key is nothing but the collection of unique things. So if you want to divide the train things like train data on the basis of train type or geographical region, so on that basis you have selected the Delhi server should contain all the bookings which has been done for Delhi location. So hence, if you want to search for any booking, you will search for this server itself, right? If it gives you the value, means the booking has been done. If it does not return you the true value, hence the booking has not been done, right? You don't need to search for Kolkata and Mumbai server. Hence, it is increasing the performance, right? This would allow the system to route user queries more efficiently and handle large number of bookings simultaneously. Means you are with the basis of shard key or directly routing the Kolkata bookings to the Kolkata server, Mumbai booking to the Mumbai server, and Delhi bookings to the Delhi server. Hence, during the search, you have already know that how searching could be more efficient, and also the maintenance and manageability of data will be so easier because you are as you have routed the number of bookings for Kolkata to the Kolkata server. So hence all the server have same or equivalent type of bulkiness of data, right? No such server will be so much bulky and all until and unless you don't have Kolkata bookings or the number of bookings for Kolkata is very less, and for case of Delhi you have too much. In that case, it will create a chaos, right? So in this Delhi server will be so heavy. So in that case also, how we manage and all things we will be learning soon. But as of now, just try to understand that how the sharding will be helpful for us to divide the data on the different servers, right? Sharding versus partitioning, that's the time here. Let's see. Sharding is the process of dividing a database into smaller distributed pieces across multiple servers. This is the main difference. Sharding also performs and do all the activities like how we have done in partitioning, which is horizontal partitioning, you can say. But it does on multiple servers. But in case of partitioning, within the same server, right? This is the first difference. Second, shards can be located on different physical or virtual machines. Data is distributed across different servers. Partitions are usually stored in the same database instance and managed within the same server. Again, the same thing. Sharding can be divided in physical and virtual machines. Like server can be for multiple servers, first thing, and the database storage can be physical or can be virtual. In case of partitioning, the stored in same database instance and managed within the same server. In case of sharding, it is highly scalable, as adding more shards can accommodate more data and traffic. Shards means if you have increased number of data, you just need to increase the number of shards, right? So if you know for Delhi, you have lot of bookings. So you can just create another shard for this Delhi server. So you can create 2 servers for the Delhi location, right? So hence the manageability will be easier. In case of partitioning, limited scalability, general improving performance within a single database instance. Because you are keeping all the database or you can partitions in the same data server, hence you can't grow much, right? Because anyhow you are making the server bulky, right? You are not allowed to make another servers, right? But in case of sharding, you are allowed to take another server to store the data, or you can basically you are allowed to make another shard also, right? Often requires additional mechanism for data redundancy and replication. In case of sharding, there might be some possibility that the data has been duplicated, right? Because you are maintaining on different servers. So basically you have to regularly keep on checking that you haven't stored the multiple or duplicated data at different shards or instances. But in case of partitioning, as you are maintaining everything at one place, so hence it can implemented redundancy within partitions, but usually handled at the database level. So here also, if there is some possibility of the data being duplicated, but it will be easily handled at the database level itself. Sharding is more complex, yes, due to the need for routing and maintaining shards. Routing means, as said, that for a particular data, let's suppose a booking has been done for Delhi and another booking has been done for Kolkata. So Delhi should be properly routed to the Delhi server, and Kolkata booking should be properly routed to the Kolkata server. Hence, this routing algorithm, maintaining of these things will be complex. That is why in case of sharding, the complexity will be high. But in case of partitioning, it is generally simpler because it involves logical division of data in one database. Because you are maintaining everything in one server, you don't need to route anything. You just need to keep, divide, and basically you can say route the database on the same server, but basically you have to logically divide the database such that it should go to the desired partitions. So hence it is simpler compared to the sharding thing, right? This was all about the sharding and partitioning difference. Please keep a note for this, because and remember it, because this question has been asked multiple times in the interview. So please note it and please remember it, because this question might be asked to you also. Next, shard key, what we were discussing, key to create shards and to route the data to the particular shards, shard key is required. What is shard key? It is a specific field or a set of fields that determine how data is distributed across different shards in a sharded database. So shard key serves as a basis for directing incoming queries to correct shards. So shard key is responsible to route and to direct the incoming database to the correct shard. So let's suppose you have to, that's what I said, ki if you have to save the bookings as per the locations, right? So if you have not maintained the shard key such that it should match with, location, then it might happen that suppose shard key instead of location, you have kept the shard key as train ID. So if it will be routed to the Delhi server, how will it check that the booking is for the Delhi or what, right? So shard key should be, the selection of shard key is very important on whatever basis you want to, you can say direct or route the database or keep the database on some condition. The shard key anyhow should include that parameter, right? So if you want to divide on the basis of location, shard key should include the location as well. A good shard key should distribute data evenly across all shards to avoid overloading. Hence, shard key is responsible to divide the data on the different shards such that it should avoid overloading, means it should equally divide on the different shards. Shard key should align with common query patterns. Shard key should have a high number of unique value, means cardinality, to ensure proper load balancing. So let's suppose in case of a booking table, a combination of train ID and date can be used as shard key. Yes, if you want to divide the database on the basis of dates instead of location, if you want to save the database in the particular shards based on the dates. So let's suppose if you want to search for 1st of October, you want to keep in a 1st of October shard. So in that case, train ID and date can be the collection of shard key, right? So together it can create a shard key. If you want to save the database in the shards on the basis of locations, so you should have first location column here also. So you can keep train ID and location as a combination of shard key, right? Train ID ensures that bookings are distributed based on the train. Yes. While a combination of date can further improve distribution by spreading the data across time ranges. So that's what, if you want to search for a particular date, you will directly go for the particular shard which includes the dates. Either you can do this sharding on the basis of date or on the basis of month also, right? As discussed, if you have 12 months, means 12 shards. So if you want to search for some date falling for March month, so you will go and search for the shard which includes all the March bookings, and you will ended up searching it too fast, right? That was all about shard key. But selection of shard key is very important, as said. Key, let's suppose if you have selected a shard key based on the first characters, right? So it might happen first characters of name. So it might happen the bookings having the A letter is so high and the booking with Z is too less, right? Or other characters. So it might happen the first shard which includes all the bookings with first character A will be so much bulky compared to the other characters R or B and so on, right? So this is not the correct way. Hence, even that's what I say ki shard key selection is very important, because in this case, if you have selected the shard key as the first character of the names, then it might happen the first shard become overloaded. But the perfect shard is that which actually equally divides the data on the different shards. So hence, instead of this, you can go with the shard key which actually selects a location or dates or months, right? Because we know month will be 12 only, right? And the dates also will be. But the first character name, you can generally understand that it might happen that the first character with A letter or some letters will be too much bulky, and the other shards with, let's suppose, Y and Z will be unused, right? So that is why the shard key selection is very important, and because it is responsible to divide the data on different shards equally, right? So that was about the shard key. Now let's move on to the shard management. It is used to maintain and handle the shards in a sharded database system, and it includes the administration of how data is split, replicated. So basically, shard management is all about when, it is about dividing the shards and routing the database to the, the predefined or, selected shards, or correct shard, you can say. And if anything happens, then, recovery for that and maintaining the database in the shards is all responsible by the shard management, right? So that is why it is used to maintain, handle the shards in a sharded database system, right? And includes the administration, how data is split, shard management will take care, replicated, duplicated, and moved or reorganized. Data is initially distributed across multiple shards based on the shard key. We know this is a method, this is the process. First process is some data will come, and based on the shard key, it will be routed to the corrected shard. As data grows, some shards may get more data or traffic than others, leading to imbalance. Shard re-imbalancing moves data between shards to distribute load more evenly. So what happens? Let's suppose you have three database for, let's suppose, January month, or let's suppose for Delhi location, Kolkata location, and Ladakh location, Ladakh. Okay, you know that you have routed all the database datas in the different shards, and as the data grows, you might see that for Delhi server you have a lot of Delhi bookings, right? So it will be more bulky, and hence in case of Ladakh or Kolkata, we don't have much bookings, so Delhi will be overloaded, right? So what you will do, you will route some of the data from this to Kolkata or Ladakh, which is less bulky, to maintain it. So all these replication of data to another servers and all, which is responsible by the shard management team. As the shard grows too large due to too much data, it may need to split into smaller shards. Underutilized shards may be merged to conserve resources. So that's what the same point. If Ladakh has very less or you can say zero bookings, so in that case, this shard can be divided into two shards. First, Ladakh will also be holding, the Delhi data, and Delhi will be also be holding the Delhi data, right? That's what it says. It is, if a shard or a node in the sharded system fails, shard management needs to ensure that the backup or replica. So that's what, if shard server will go down, right? So if user or customer is fetching or wants to fetch the data and server is down, so he won't get the data, right? So that is what replication is also very important, means keeping a duplication of data, such that if server goes down, another server will, give the data. So it is all maintained and managed by the shard management team, right? So now next is shard rebalancing. Similar in case of, failure, how one or two server can combine. The underutilized server, which have less bookings or less data, can combine and can keep the data from the, the overloaded server, and can maintain and make the efficiency better. So shard management redistribute data across shards in a sharded data system to ensure the data is evenly distributed and that no shard become performance bottlenecks due to uneven data or query. Okay, so shard reimbalancing only comes into picture that once all the data from the database on the basis of shard key has been divided on different shards. But now, as the data grows, some server might become bulky, some server might become underutilized. So for that scenario, on the basis of condition only, Delhi locations bookings has been routed to Delhi location, right? And on the basis of the conditions only, Ladakh bookings has been routed to Ladakh. But now as the data grows, the Delhi server become more bulky. So now the maintenance and manageability is responsible by the sharding management, and rebalancing means whatever data the overloaded server, taking some data from the overloaded server and saving it to another shards of another server, means underutilized server, right? So to address server loading, let's suppose in this case we have Ladakh server and Goa server and Mumbai server and Bangalore server. To address server overloading, the Mumbai server being overloaded. Okay, so this is a Mumbai server and it is overloaded. IRCTC can implement shard rebalancing by directing some of the Mumbai server traffic to Goa or Bangalore server. So if we know that Goa and Bangalore server has some space and it is not overloaded, so because of it, the Mumbai server is overloaded, we will route some of the data or request to the Bangalore and Goa server, right? So this is Ladakh server, and Ladakh server, you can see it is underutilized because it has 0 or less data, right? So to address underutilized servers, we can combine low volume regions to reduce infrastructure cost while maintaining performance, right? So if we know that Ladakh server, we don't have much request, so we can reduce this, we can reduce the infrastructure cost also, and maintain the performance level. And if we know that Mumbai requires more server, so we will give it to this instead of the Ladakh. So that is what, maintaining the overloaded server and the underutilized server is the responsibility, and in this case rebalancing means. And what is the rebalancing, shard rebalancing is all about, right? Next is replication. So replication is nothing but keeping a duplicate data already stored such that it will be served, and it will serve the customer's request, especially when server goes down, right? So replication in sharding refers to process of creating multiple copies, which is replica, of data across different shards to ensure high availability, fault tolerance, and data durability in a distributed database system. That's what it's all about, keeping and saving a replica of the database so that it will be served, the data will be served 24 hours, even if the server goes down, right? In a sharded environment, the data is distributed across multiple server node based on a shard key. We know that. Replications is important to prevent data loss and ensure that the system remains operational even if some nodes fail. That's what. So let's suppose here server A and server B, we have two servers, and we have created a replica server for both the servers also, where we have saved the duplicated, like we have saved the copy of data right here. So even if the server goes down, the consumer won't feel any downtime, because the replica server will serve that. So that is all about replication in sharding, and why it is important we already know, to face no downtime even if server is down, right? So that is all about the sharding, difference between sharding and partitioning, what it is, and how we manage, why we manage, how we route the data in the different shard based on the shard key, how selection of shard is very important and how should we select it, right? And what is the meaning of replication in sharding, right? So we have learned all about these important concepts. I hope you learned and understood and you won't forget, especially during the interviews. So that is all about the whole lecture. I hope you learned. Now let's meet in another lecture. Till then, keep learning, take care of yourself and your family too.